Hello everybody, welcome back for part 2 of lesson 1-3. We're going to talk about a little more about intercept, and then we're going to talk about end behavior, what happens to the graph in the ends. There's something called the intermediate value method. It's a method to help us approximate the zeros, which is another way of saying x-intercepts. Now, this is important, approximate. This method is not going to get us the actual x-intercepts like we did last time, right? Make y 0 and solve for x. We're not going to do that, okay? So this is going to be approximate. We're going to get really close to it. All right. So first, you can pause and copy this quick graph. Let's look at a graph and notice if I have an intercept at the intercept, right? To one side, it's got to be under, the other side's got to be over. Think about it. The only way that you can have an intercept is if you go through it. That means you go from one side to the other side. So that's important to know. So if we plug in A and we get a negative answer, and we plug in B and we get a positive answer, doesn't that mean that you're going from negative to positive? So you're crossing the x-axis, so you must be having a x-intercept there, right? So that's what I wrote here. Notice that f of a, if I do the function of a, I'll get less than 0. F of b is more than 0. Then 0, the x-intercept, which here we call c. This number here must be between a and b, right? So if all these numbers were here, if all of these were numbers, I could say, oh, the intercept is between 1 and 5. What is it? I don't know what it is, but I know it's between 1 and 5. How do you know? Because when I plugged in 1, it gave me a negative answer, and I plugged in 5, it gave me a positive answer, so the intercept must be between. Okay? Let's see an example with real numbers. So, approximate the zeros using the intermediate value method. So, here's your function, and I'm telling you, go from -4 to 4. You don't have to do the rest. You don't have to go to infinity or anything. Between these two numbers, are there any zeros, any intercepts, right? So let's try everything. Let's plug in everything from here to here. -4, -3, -2, -1, 0, 1, 2, 3, 4. Plug them in and see what you get. Okay? So I'm going to plug in -4. It'll give me an answer, positive or negative. I'm going to plug in -3. I'll get an answer, positive or negative. Then -2, then -1, then 0, then 1. All of these, I'll plug in, I'll get an answer. You just have to remember that whenever we go from positive to negative, you're dealing with an intercept. So here are the answers. After I plug in -4, I got -46. After I plug in -3 in here, right? I get -13, etc., 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 etc. Now look at your answers. Negative, negative, positive, 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 negative, positive, positive, positive. So right here, there is an x-intercept between -3 and -2. How do you know, Mr. C? Because this one gave me a negative, this one gave me a positive. So I must have crossed the x-axis for that to happen. So I know between -3 and -2, there's an x-intercept. Oh, look, it happens here too. It doesn't happen here. Positive, 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 positive. Positive, negative. We're going from top to bottom. We're crossing this way, somewhere. Well, I know it happens between 0 and 1. because 0 gives me a positive, 1 gives me a negative. And then I know right away it happens again between 1 and 2. Right? Because we're going from negative to positive. So we'll talk more about this in class, but I would imagine, if I had scratch paper, I would imagine that the graph goes through -3, -2. So it goes through here, and then, right, between -3 and -2, and then it goes through 0, 1. It goes through here, and between 1 and 2, it goes here. So maybe I don't know what the graph looks like, but maybe it's something like this. Right? Intercept, intercept, intercept. Well, what are those numbers? I don't know exactly, but I got an approximation. And that's what we're looking for. Approximation. I got a rough idea between -4 and 4. I got a rough idea that there's 3 intercepts and where they are. Okay. Oh, I did it on scratch paper, but I did it here too. You don't have to copy this. This is just to show you that the zeros are between here and here, here and here, and here and here. You know what? I changed my mind. Do copy this. This says what this says, but in case you don't realize what this was going on here, this is what we found out from here. Between -3 and -2. Between -3 and -2, there's a 0, because we go from negative to positive. Between 0 and 1, between 1 and 2. Okay? So I don't know, maybe the graph, like I said, goes something like that. Like that. Something like that, maybe. Okay. So that's the intermediate value method of approximating the intercepts. Let's talk about end behavior. End behavior, what that means is we want to know, lots of things happen close to home, close to 0, right? The curves and all that. But what happens all the way in the ends? Like, what if x was like 1,000,000? What happened if x equals 1,000,000 and x equals -1,000,000? Way out there. What happens out there? Well, here's the way to write it. What we're asking, what's the limit? Where does it go? Where does your function go as we go to the left, all the way to -infinity? And we want to know, where does it go? What happens as it goes to the right, positive infinity? Right? What does your graph do way out there? Well, why don't we do that? Why don't we pick some super huge numbers? We didn't get to the numbers yet. I want you to see a graph first. Notice this one, right? As we go to the left, our graph goes up. As we go to the right, our graph goes down. So that's what I'm saying here. As x goes to the left, the function goes up to infinity. As my x goes to the right infinity, what does the graph do? Go back up? Positive? No, it goes down. -infinity. Okay, so this is just a way of writing what's happening as you go to infinity, as you go towards the end of the graph. Okay? Here's an example. Boy, you need a second to copy that, huh? Long function. Okay? So, what I want to know is, you know something's going to happen at 0. It's got to be close to 0. But 1, -1, 2, -2, that's not the end. Let's go way out there, like lots and lots of zeros. -100, -1,000, -10,000. If you don't mind, why don't you keep going like -1,000,000. And then the other side, really big numbers. We want to know what's going on. Now, before I reveal what's going on, most likely, as we go to the left, what's the possibility? The function can go up forever or it can go down forever. So we'll see what happens down here. How about as you go to the right? It can go up forever or down forever. We'll see what happens. So you plug these numbers in here and you get these values. Now these scientific notation numbers, that's the way the calculator gave them to me because they're so big. But look what's happening. As we go to the left, the number gets bigger and bigger and bigger, but the negative direction, down. As we go to the right, it also gets, the numbers get bigger and bigger, but negative direction. So, is it going to be like this? As we go to the left, it goes up to infinity? No. As we go to the left, it goes down. Right? It gets further and further down. How about the other direction? As we go to the right, does it go down? Yes, it does, actually. This does the same thing. So it goes down. As x goes to positive infinity, my function, my graph, goes down infinity. And here I'm saying as x goes to the left, negative infinity, my graph goes down. So it must be a U shape upside down, a U shape like this, upside down, because they both go down. Whether you're going to the left or to the right, both go down. Okay? All right, so let me leave you with a couple of try problems. Number one, like the first example, between which integers the zeros are located. So, between -3 and 2, tell me when it goes to positive or negative. Maybe once, maybe twice, maybe never. Maybe it all stays positive or all stays negative, never switches. So every time it switches, there's a 0 there, just like before, from -3 to 2. And then plug them all in and see what happens. Right? You're looking at the sign. When does it switch signs? And then describe the behavior. So start your chart, 0 in the middle, and then 1,000, 10,000, 100,000 to the left, 1,000, 10,000, 100,000 to the right, and see what happens when you plug those in. Okay? Do them just like the examples. We'll go over it in class. If you have any questions, just remember them from class. All right. See you next time. Bye.